Okay, today we'll talk about square roots. And there's a symbol that we use for that, and it's called a radical. And it looks something like this, like a check mark with a line over it. It's called a radical. Okay, what we have here are square numbers. For example, here we have 1, 2, 3, we have 4. 4 is a square number. You take 4 dots, you can make a square out of it. Same thing with 9. Because you make it 3 by 3, there's 9 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they can make a square. So that's considered a square number. 4, 9. The next one would be 4 by 4. That's 16. 5 by 5, 25. And 6 by 6, that's 36. Matter of fact, these are called square numbers. Square numbers. Now, since they make squares, one side, for example, this side here, a side you can think of as a root. Think of a side as being a root. So I'm just going to make this right here. All right, and that's what we're looking for when we're looking for numbers. We're looking for the square, the root of it. I know that sounds kind of strange, but that's what we're doing. Now, this will make more sense as we go along. Now, I told you before, this is what they call the radical symbol. Now, if there's a 2 in there, sometimes that's called a square root because we're looking for 2 of something. If it's a 3 or a 4, it's called something else. And this is what you'll be doing next year. Now, normally this 2 right here is invisible. But we usually don't write it down. This is what we're usually looking for, the square root. This is called a square root. If there's a 3 in there, in this radical, right in this little part right there, that's called a cube root. We're looking for the cube root. If there's a 4 there, we're looking for the 4th root. Okay, so we're just identifying what this stuff is. Now we'll go ahead and figure things out. So we have a square root, a cube root, and a 4th root. We're just going to be dealing with square roots today. Just square roots. Now a lot of times we don't put the 2 right there though. We leave it invisible because everyone knows that if we have this, if it's just invisible, we're looking for 2, a pair. Okay, so we have square root, cube root, 4th root. Square root means that only 2 of the same number, can jump out. We're going to have numbers inside here, and only 2 of the same number can jump out. For cube root, you'd have 3 of the same number that can jump out. 4th root means 4 of the same number can jump out. So it's kind of like a little game here that we're playing. By the way, over here, can you please put this note that this, if there's square root and there's nothing inside there, or if you have square root 1, it's the same thing as 1. Just a square root symbol or a square root with 1 inside of it, it's equivalent to 1. It equals 1. Okay, just kind of keep that in mind. That's just a rule that we have. Okay, let's go to some problems. This will all make more sense to you. Okay, our first problem is square root of 4. Okay, what we want to do is break the 4 down so we have a pair of numbers that jumps out. Now, isn't 4, I'm going to break 4 down. 4 is the same thing as 2 times 2. Right? That's a pair. So we have a pair of 2s. A pair of 2s can jump out of this little box, this little radical. It can jump out. Not both of them, just a pair as itself can jump out. So I have nothing left inside here. Well, if there's nothing left, that's the same thing as saying 1. And this is 2 times 1, so our answer is just 2. I know that's a little confusing right now, but just hang with me here. So I took the square root of 4, and I ended up with 2. Notice when we go to the number 4, a square of 4, the root of it, one side, is 2. All right, let's go on to another example. Okay, square root 12. We need to break 12 down. Well, 12 is 2 times 6. Hey, wait, we can break 6 down even more. I'll bring the 2 down. 6 is the same thing as 2 times 3. Okay, look, I have a pair of numbers that can jump out. Here's a pair. They can jump out. So if they jump out, what do I have left inside? A 3. Now, I don't have a pair of 3s, so the 3s can't jump out. So that 3 has to just stay inside there. And this is our answer. And we would say 2, you could say 2 square root 3, or you could say 2 rad 3. That's kind of a shorter way of saying it. 2 rad 3. So radical 12 or rad 12 or square root 12 is the same thing as 2 rad 3. Or 2 times rad 3. Now you may be thinking to yourself, okay, square root 12, I don't know what that is, and I don't even know what 2 square root 3 is either. How are those as far as numbers? All right, let me just show you on a calculator. If I take a calculator and I press in 12 and I square root it, okay, it's that's a decimal point there, 3.464, yada yada. All right, now let me do the same thing with 2 times square root 3. Let's see if I get the same number. So if I press, I'm going to do square root 3. So I'll do 3 square root, and I'm going to times it by 2. Times it by 2. And that equals, look at that, same answer. Same answer. So see, these are equivalent. It's just that I simplified this to that. I simplified it. Sometimes they're not nice, neat numbers. Okay, next, square root 75. Okay, what can you think of that goes into 75? How about 25? Right? 3 times 25 is 75. Can we break down 25? Yes, we can. Okay, so 3, and then 25 is 5 times 5. Do I have a pair yet? Yes, I do. I have a pair of 5s. This pair right here can jump out. So I will jump it out. Is there anything left inside? Yeah, the 3. And that's it. So that's our, see, I don't have any other pair of numbers to jump out of this radical. So that is my answer. So basically what we're doing is we're simplifying these square roots. Okay, just going back up here for a moment. Remember, the 2 is usually invisible. When it's invisible, we know that it's the number 2. But if they want a 3, a cube root, or a fourth root, they'll put that in there. And what this means is you need 2 of some number to jump out. 3 means you need 3 of the same number to jump out. 4 means you need 4 of the same number to jump out. Okay, but again, we're just dealing with square roots today. Okay, here's our fourth example, square root 45. So we need to break 45 down. Let's find out if there's any pairs that can jump out. So 45, that would be 5 times 9, right, is 45. Okay, can we break 5 down? No. Can we break 9 down? Yes. 9 is 3 times 3. Hey, we have a pair. This pair can jump out. So if I jump this 3 out, what's left inside? It's just a 5. So I simplified this, square root 45, to this 3 square root 5. Okay, square root 32. Okay, let's figure it out. First thing I can think of is 4 times 8. That's 32. Now the 4, that can be broken down. The 4 is 2 times 2, right? Now, if you want to, you can break the 8 down, or, well, I'll break the 8 down now. So 4 times 4 is 2 times 2. And then I have 8, and 8 is 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. So this is 4, and this is 8. Wow, we got a bunch of pairs here. 2 pairs. So let's pull out this pair first. If I pull this one out, okay, I'll pull this out. I have a 2. On the inside, I have 2, 2, and 2. Okay, so now I have another pair that can jump out. And so if I bring this pair out, now what do? Do I add the 2 together, the 2 2s, or do I multiply them, or what? Here's the way it works out. This 2 is there. If I pull this pair out, I'm going to be multiplying, because what's left inside there is a 2. So remember, if you have 2 square root all this, this is 2 times it. So if I pull this out, it's multiplied. Just like I have my answers here, this is 3 times square root 5. So if I pull these pairs of 2's out, I have this. But wait a minute, 2 times 2 is 4. So my answer is 4 rad 2. So just back up again. I broke this down. Matter of fact, it came out to 2 pairs. 2 pairs. So this pair jumped out. That leaves me with 3 2's in there. Then this pair of 2's jumps out. And so now I have 2 2's on the outside and square root 2. So the answer is 4 rad 2. Very tricky. Okay, one last one. Most of your problems will not be as difficult as the ones that we have done. Here's an easy one, square root 49. Well, 49 is 7 times 7. Hey, there's a pair. That pair could just jump out. And you have nothing left inside here. Okay, so there's nothing left, so that's it. It's done. It's 7. You don't have to write square root nothing. Just, it's 7. Okay, on the estimating numbers, let's go ahead and just write the numbers 1 through 20. I don't know how far it goes, but put inside the radical there. 1, 2, 3, 4, etc. Just work your way down. Okay, line goes down to 28. Okay, so you have those numbers in there, 1 through 28. Now, these the ones that I put in boxes, they're the ones that end up with whole numbers. So, for example, square root 1. Remember, I told you that square root 1 up here is 1. That is equal to 1. Square root 4. Well, remember over here, we did this problem right here. Came out to 2, right? And the square root, if you take a number, make it into a square, the root of 4 is 2. So that is 2. And of course, square root 9, that's 3, because 9 is 3 times 3. 16 is 4 times 4, so it's 4. 25 is 5 times 5, so it is 5. Okay, so we know these 5 of them. The question is, what about the ones in between? We need to estimate what are they closest to. What are they closest to? So, to the nearest whole number. So, let's do that for now. Okay, so if it's square root 2, is 2 closer to 1 or is 2 closer to 4? 2 is closest to square root 1, so it's going to be closest to 1. It's going to be about, see those are approximately symbols? Approximately 1. How about rad 3? That's closer to rad 4, which is 2, so rad 3 is approximately 2. So do you see that square root 2 is close to the square root 1, which is 1, and square root 3 is closest to square root 4, which is 2. So square root 3 is about 2. Let's go to square root 5. Square root 5, well, that's about 2, isn't it? It's either between 2 and 3. Square root 5 is between 2 and 3. It's closer to 2. How about square root 6? Is that closer to 2 or is it closer to 3? It'd be closest to 2, right? Because it's closer to square root 4. Actually, let's see. No, it's about that. Okay, 7, that's closer to square root 9, which is 3. So this is going to be 3. And 8, that's closest to 9, so that's going to be 3. So you see what I'm doing here? I'm estimating what is it closest to. And if I use a calculator and punch in these numbers here, for example, I'll do square root 5. Square root 5, so I'll press in 5, and I'll hit the square root button, and I get 2.2. See, it's closer to 2 than it is, it's closer to 2 than the number 2 than it is the number 3. So we're estimating its value. How about 6? Let me just curious to see if we did that correctly. So if I press 6 and I square root it, 2.4, 2.44, 2.45, and we said square root 6 is closest to 2 and not 3. And that's right. We are close to that. If I did square root 7, right, I'll just do it real quick. I'll press 7 and I'll hit the square root button. And look at that, 2.6. It is closer to the number 3. 6 is closer, 7 is closest to the number 3. Okay, so hopefully you get the idea there. All right, so 10, obviously that's going to be closer. It's going to be between 3 and 4. Right? These numbers are between 3 and 4. What are they closest to? Square root 10, if you put in the calculator, it's going to be closest to 3. Square root 11, well, that's obviously going to be closer to 3. Square root 12, is that closer to 16 or is it closest to 9? It's closest to 9. So that means it's going to be approximately 3. It's going to be closer to 3 than it is 4. All right, 13, well, that's closer to 16 than 9. So I would give that that's about 4. And these other ones are about 4. Right? They're closer to 4 than they are 3. So we're estimating their value. Okay, next one. All these numbers, all these square root numbers are between 4 and 5. Square root 17 is obviously closer to 4. It's about 4. 18, it's about 4. Square root 19 is about 4. So let's see. How about square root 20? Is that closer to 16 or 25? Yeah, that's closer to 16. So it's closest to 4, because 16 is 4 times 4. 21, well, that's closer, I think, to 25. So that would be 5. And the rest of them, that would also be 5. And then obviously the last two, well, they're closer to 5 than... See, the next one up would be square root 36. And square root 36 is 6. So you know that these are much closer to 25 than they are 36. So these must be about 5. And so that is how we estimate our square root numbers to what are they about.